Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6,000 worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians, welcome to the podcast where math is figureoutable. I'm Pam.
And I'm Kim.
And you found a place where math is not about memorizing and mimicking, where you're waiting to be told or shown what to do. But y'all, it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can mentor students to think and reasons like mathematicians did when they were students. Not only are algorithms not particularly helpful in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be.
We don't want to do that, right?
That's right.
We don't keep. Hi, how are you?
I'm crazy. How are you?
Yeah. Living my best life. Can we tell people that we aren't in the same room? Is that a thing?
Well, it's funny because when we were at NCTM, people were like, "You're not?" When
I know.
we chat about it a little bit. Yeah, we're not. Yeah. We know each other well, though. Maybe too well sometimes, but we've how long have we known each other? My son had you in 3rd grade, and so he's now 20 some.
I think 21 years.
Yeah, it's been a hot minute.
Okay. Hey, I like to find a review every now and then, and like people have given us some really good ones, so I keep throwing some in here. But
we sure appreciate it.
Yeah, it is super fun. So, the one I want to share with you is super short, but it's from I'm Loving Mental Math. That's the handle.
Nice.
And I don't know if it's I don't know who it is, but I'm going to say they. So I love this podcast and recommend it to all the math teachers I work with at our small school. Over the summer, I do know. Over the summer, my husband, a computer engineer, has started listening with me too. Keep up the excellent work. Isn't that fun? This person got their husband to listen. And I wanted to tell you, did I tell you that my dad
family math
started listening every once in a while?
No.
Isn't that hilarious?
That's awesome.
Yeah, they were on a road trip. And he said, "Hey, I listened to your podcast." Ooh, okay.
Oh,
super sweet.
You stood up proud and said, "Sweet."
Oh, it's super fun. Yeah, he's kind of mathy.
That's cool. Well, family math, that's the best. That's
super fun.
We encourage everybody to listen. Listen as a family or whatever.
Super fun.
Cool.
Thank you. I'm loving mental math.
Yeah.
Okay, so we recently did a couple of episodes about integers, right? That was episodes 181 to 183. And
hey, Kim.
Yeah.
I have to tell you, so I was talking with one of my kids. I believe it was the kid who was here for Thanksgiving. So maybe I just won't tell you which one it was.
Oh, okay.
Anyway, and he said, okay, now you know it's one of 3. He said, "Why do you say integers when you are talking about negative and positive numbers?" And I was like, "Well, that's the name of the set." I got all kind of teachery. That's the name of the set of numbers when it's negative and positives. He goes, "No, I know that. But when you're talking about positive integers, you're also talking about integers." I was like, "Yeah, true. Whatever, snot nose." Yeah. But I said,
kids.
I know. But then I said, but I'm using the more specific set. Because when I'm only talking about positive integers, then I can call those the natural numbers. Or if I'm including 0, I can call them the whole numbers. Ha! Anyway, okay, carry on. Yes. Yes, so we did some
about negative integers.
We had both. They were negative and positive, but yeah.
Okay. They were, actually.
Yeah.
Okay. Yeah. Well, anyway, we thought we would follow up with one more for you because there's always more to do, right?
Absolutely.
So we are going to give you a heads up that we would not do these strings that we're going to do some strings, and we would not do these if we had not already established first what integers are, and then done some work on subtraction as difference versus removal. So if you haven't heard the last episode, this isn't going to make a whole lot of sense. So stop right now, go back and listen, especially to episode 183.
Yeah, because it's really important that there's some sort of groundwork things that we would do with students. That doesn't mean that they've owned them completely, but they at least have these ideas floating around. They're playing with some different notions about like, what does it mean to be an integer? What does it mean, integer? All right, Craig, what does it mean to be a negative number? And how does that relate to a positive number and distance from zero and all that kind of stuff. And then also the idea that subtraction can be thought of as two ways, like you said, as difference is the distance between numbers, but it can also be thought as removal or minus, which is typically the only one that many of us ever have with subtraction, because that's the typical meaning that we pull into the algorithm, is that we're always subtracting these single digit integers. But we need to know that subtraction can also have this idea of the distance between numbers. And you might be like, I don't know, really, because my kids have got all the rules down, the rhymes or raps or mnemonics, or like, for example, I was working with a group of 6th grade students who had already they had done some meaning of negative and positive numbers. And then and the teacher was very clear, I talk about how it works and why and meaning, but then we do get to the rule. For example, they had Pizza Steve. They had one that was minus plus plus. As I was walking around and kids were solving problems, I heard a lot of kids saying minus plus plus. And a few times I would say, like, when do you do that? And they're like, I don't know. When you see two minuses, then you just do plus plus. And I was like anytime? And they're like, yeah, anytime you see two minuses. And I was like, anytime, like addition, subtraction, multiplication, division, plus, minus, plus, plus. That's a bit of a problem if it is any operation. Anyway, so they had some sort of all these rules kind of floating around, and it became really clear that that's what was happening. Was there was all these rules floating around. So it's not about rules. We're going to do a string today, Kim, on the podcast, where it's not about turning this into a rule. It's about understanding what's happening and generalizing some patterns. We need one more thing before we do this particular string. I think it was episode 183, I think, we tried to establish that another big idea, which is, if we are subtracting and I say to you, hey, Kim, like you've been doing since 2nd grade, you've got a number and then we're going to subtract something smaller than it. So like, I don't know, 8, and then we subtract something smaller than it, 2. And if I say 8, subtract 2, then you would obviously say 6, and it's a positive number, right? If I have a number, and from that number I subtract something smaller than it, 8 subtract 2, then you still have stuff. So for example, if I've had money, we had $8, and I give you $2, we still have $6. Or if we're at 8 feet above sea level and we drop down 2 feet, we're still 6 feet above sea level. Okay, what's another one? Money. If you have $8 and you spend $2, you still have $6, right? We're still in the black. We still are positive if you've removed something smaller than what you started with. And that makes sense to everybody because you've been doing that since 2nd grade. But then we also developed in 183 that if you remove something larger than you started with, so you started at 3 feet above sea level and you drop down 5 feet, 3 subtract 5. Well, now you've gone through the 0, right? You've dropped down below sea level. And so 3 subtract 5, where are you, Kim? 3 subtract 5?
-2.
You're at -2 because you dropped 2 below the sort of sea level. You can do the same thing with temperature. If we were at, what numbers did I just use? 3. If we're at the 3 degrees above 0, it's cold, but it's not freezing yet. And then it drops 5 degrees, you're 2 degrees below. So if you're at 3 and you subtract something more then you have to drop through the 0, right? If you have a number and you subtract something more than it, here's another one. I've got $10 and I pay you 12. That's kind of funky with money.
You owe me 12.
Yeah, well, if I have 10 and I pay you 12, then I can hand you 10 of them, and now I owe you 2, right?
2 more,
so yeah. So as soon as I subtract more than I have, I'm in debt. I'm below sea level. I'm below the 0 on the temperature. Okay, so we kind of have to have both of those things happening in order for this string to make sense. So I may have taken too long to get all that. If it's the first time you've heard any of this, really maybe go back and check out those other episodes. But here we go. All right. So Kim, we play a lot of football here in Texas, yeah?
I don't, but a lot of people do.
There you go. We don't actually at my house either. I can't get anybody to watch it with me. It makes me crazy. Anyway, in American football, we have this thing, this line of scrimmage. And when you are playing, the line is kind of where you measure everything from. And you have 4 tries to get past that line. And so the other night, there was a football game on, and the team had gotten pushed back 8 yards behind the line of scrimmage. So that's not good, right? Because now you've got not only the 10 yards you need to get past that line, but now you're 8 yards back. So you're really, it's terrible. Everybody's sad and stuff. And then the announcer says, oh no, the team got pushed back 7 yards. That's terrible.
Yeah.
So as I would say that, I would, with kids, I would like sort of act that out a little bit. So can you picture, Kim, where did we start?
I actually drew a number line while you were telling the story.
Tell us about it. Yeah. Like, what are you picturing?
So as soon as you said we started 8 yards back, I drew 0 on my a number line, and then I put -8 to the left.
Mm-hmm. That's where we started. Yeah.
And then when you said we got pushed back 7, I drew a jump back of -7. So I have a -8 -7, and then I landed at -15.
So like the football team's terrible. Like we're clear back at -15. So I would want to establish that with kids, like what really happened. And then I would say, so we started at -8, we were pushed back 8, and I would write -8 on the board. So not number line or anything, just the number, -8. And then we got pushed back, and I would write a minus sign, a subtraction sign. We got pushed back 7. So now on my paper, I've got -8 minus 7. And I would say, so I'm saying the thing in context. We started 8 yards behind line of scrimmage. We got pushed back -7. And you guys all just, and then equals, and I'm writing equals as I say, and you guys just said we landed at -15, and then I would write -15. So right now on the board, I've got -8, -8 minus 7 equals -15. Does that make sense?
Yep.
But it was totally in context. Cool. All right. So then I would say, hey, then later in the game, that defense, they were just, man, they just kept pushing us back. We got sacked 8 yards back from the line of scrimmage. So we're 8, it felt like we've been here before. And then the announcer says that the team now has a loss of 7 yards. Where are they? And most of the kids at this point, well, I guess I could just say, Kim, where are we?
Same place.
Because most of the kids at least are kind of like the same, almost intonation, same place. And I'm like, well, say more about that, because then I'm going to write on the board, we got sacked, we're back 8 yards, and right underneath the equation that we just had, I'm going to write -8. We got pushed back, we're sacked 8 yards. And then the announcer said, we have a loss. And so as the announcer says have, I'm going to put a plus sign, and then I'm going to put -7 for the loss. So we started back -8, I've got -8 plus -7. And you guys are saying same place, -15. So now I have 2 equations on the board. Probably your same number line on the board. You know, like if we had the 0, we were back -8, we got pushed back 7. But the 2 equations I have on the board, the first one, -8 subtract 7 equals -15. And the second one, -8 plus -7 equals -15. And then I'm just going to go, and then I'm going to go into the next question. Cool. So next question. Let's say that you've got $9 and you owe me $12 and I'm standing in front of you. So I'm going to say you have a debt of $12. So I just wrote on the board 9, or on my paper, 9 plus, because you have a debt, 9 plus -12. And you're standing in front of me. What are you going to do?
I'm going to give you the $9 back.
Okay.
So on my number line, I'm subtracting 9. Now I'm at 0. I'm going to tell you, hey, I'll get you next time. I owe you 3. So subtract 3, and now I'm at -3.
Cool. So I've got on my paper 9 plus that debt of -12. So 9 plus -12 equals you're in debt -3.
Okay.
Cool. Next problem. What if we've got $9 and you hand me $12? Like, how do you do that? I don't even know.
Yeah.
So $9 and you're like, here's $12, and I'm gonna go, yeah, but you only had 9.
Yeah. So I'm at -3. Can I suggest that, like, that one? I almost want to do a different context. Like if it's temperature, it would be a nice one for that one.
All right, go for it. What would your temperature sound like?
So if I'm at 9 degrees and it drops 12 degrees, then I would be at -3.
Bam. I like that. We could also maybe even do elevation. If we're 9 feet above sea level and we
Mm-hmm.
fall 12 feet,
Yeah.
then you would be 3 feet below. So let's say what that equation looks like, 9, and then
Mm-hmm.
fall or drop is that minus, subtract,
Yep.
12, and then we're saying equals -3. So
Yeah.
now we have two equations on the board. One of them is 9 plus -12. That was where we added a debt of -12. 9 plus -12 equals -3. And 9 minus 12 equals -3.
Mm-hmm.
And then we notice again,
Mm-hmm.
what are you guys thinking about this? And then we would have a conversation with students about what they're thinking as this is happening.
Yep.
All right, next problem. What if I were to just put on the board 3 subtract 7 and then ask what kinds of contexts could you guys come up with where we actually would ever have 3 minus 7? So,
Mm-hmm.
listeners, you guys think to yourselves, 3 subtract 7, if you were doing elevation or debt or temperature or football, what could you say that could represent 3 subtract 7? Okay, Kim, do you want to choose one or do you want me to go first?
You can go first.
Okay, so I'm going to have a temperature of 3 degrees and it's going to drop 7 degrees. So if I start at 3 and now I'm doing a vertical number line, I start at 3 and I drop 7, I'm going to drop through 0. So I've got to jump a 3 to 0. But I have to jump 7, so I've got to jump 4 more and I'm landing at -4. So 3 subtract 7 lands me at -4 degrees. Burr.
Mm-hmm.
Okay. Do you want to?
Yeah, I would bet that my number line looks just like yours, except I actually am not on a horizontal. I'm on a vertical number line because I'm going to be elevation and I'm going to start at 3 feet above sea level and I'm going to jump.
Nice.
So I'm hitting sea level at 0 and then I'm in the water -4 feet.
Down -4.
Mm-hmm.
Nice. So a couple different contexts that could work for that.
Yeah.
What then if I put up 3 plus -7? And you want to go first or me? Choose a context that would make sense for that problem.
I'm going to go money, I guess, on this one.
Okay.
So I have $3 in my wallet, but I also owe you $7.
So you have a debt of
Yeah, I have a
$7.
debt of $7.
3 plus -7.
Mm-hmm.
Nice.
And so overall, I have a negative balance of -4.
You've
I
got
have a
negative.
balance of -4. Mm-hmm.
Yeah, nice. And I might go football on this one. I've gained 3 yards, so I'm 3 yards in front of the line of scrimmage. And the announcer says, "Oh no, now they have a loss." That's why I'm saying. I know it's kind of tricky. People are like, "Really?" Right. It's not like it's super clean, but we can make some sense of 3 plus -7. I started at 3 yards in front of the line of scrimmage. Now there's the plus. I have a loss, -7. 3 plus -7.
Mm-hmm.
So I'm back. I was 3 ahead, but now I've gotten pushed back 7. And so now I'm horizontal again and I'm back 4 from the line of scrimmage. So that's where the -4 comes in. And again, now I have on my paper 3 minus 7 equals -4. And below it, 3 plus -7 equals -4. Did you want to say something?
Yeah, I don't know if there are more problems, but as you're saying these, it feels like there's some pairs here. And for one problem in each pair, it feels to me a little bit more like starting at a location and movement happening.
Mm.
And then for the other type of problem, it feels like 2 separate events happened or 2 separate things have happened. And
you're kind of putting them together?
You're kind of putting them together. Yeah.
But,
so for that, it feels like maybe I would change context between the 2 problems.
Very
like
nice.
The very first one, when you said football and then another football, it felt too similar to me. But I wonder if the football thing worked for me with the -8 minus 7, but then I would change a context for the second problem of that pair.
So I hear you saying that the subtraction problems feel like movement, like you're removing, you're falling, you're being pushed back, you're spending money. And the adding a negative problems feel like you had a debt of $8 and now you have another debt of $7. So -8 plus -7 feels like, well, now I had 2 debts and they're kind of,
Yeah.
there's not like some action happening. You've got this debt, you've got this other debt. How much debt do you have? Well, I'm combining them. I've got a debt of 15.
Yeah.
That kind of idea.
Yeah. And I feel like maybe that's why it's so important to have several different contexts in mind. Like be able to change between different contexts, because sometimes I think we force one context into a situation and it doesn't really work as well.
Mm. Mhm.
So when we only have one context in mind and they're like, well, I tell my kids think about money, or we say, think about money, maybe that doesn't fit as well for a particular problem.
Mm-hmm. Yeah, and I've got one for you in just a second.
Okay.
So once we have these 3 sets that you said there were like in pairs on the board, so -8, subtract 7, and -8 plus -7, and then we had the 9 and 12s and the 3 and the 7s. Once we have those pairs on the board, I would step back and I would say, just looking at the numbers, what patterns do you see? So, Kim, got any patterns that you're noticing?
Patterns I'm noticing.
And I know I'm putting you on the spot here.
No, it's okay. I mean, they're all negative.
All the answers were negative? Yeah, yeah.
Not every time. In some of them, you're starting with a larger number and you're subtracting a smaller number in the second and third pair.
Okay.
Oh, that happens in the first 2. Okay. So you're starting with a larger number and subtracting a smaller number.
Give me an example. Where
9,
did you...
9 minus 12.
So you started with 9 and you subtracted something.
So you're starting with a larger number and subtracting
from a number. From a number. From a number.
So you're starting with 9 and you're subtracting 12. So you're subtracting something larger.
Which is why you kept getting negatives.
What did I say that backwards?
Well, you did the first time, but it's okay. So like from 9, you subtracted something larger than it. You subtracted
which is
12.
why you're ending with a negative.
Which is why you ended with a negative. Or even -8, you subtracted 7. 7's much larger than -8, which is why you got -15. 3, you subtracted 7.
Yep.
That's something larger than 3. So then that's why the answer is -4. Okay. Yeah, that was consistent.
Okay.
And if you look at the pairs, one relationship that I would want to bring out is if you're subtracting a number, can you also think about that as adding its opposite? Does that track? So like if we look at the first
for like 3 plus -7?
Yeah, so we had 3 subtract 7 and you said that was -4.
Yeah.
Can you also think about that problem as 3 adding the opposite of 7, which is -7?
Yeah.
And we could see that if you were on, this podcast. I have no idea what people are envisioning right now, but on my paper, I have 3 subtract 7, and underneath it, I have 3 plus -7, the opposite of 7.
Right.
So sometimes people will say, well, I can subtract, but I can also think about it as adding the opposite. I can lose money, but I can also think about it as adding a debt.
Right.
Yeah, cool.
Well, but do you think that, it seems to me like there's a lot of missed opportunity to thinking about the subtraction symbol as opposite as well. I think for so many years in elementary and as we're entering middle school, they only think remove, minus, minus, minus. And so when somebody sees -7, -7, whatever you want to call it, I don't know that kids go, oh, that's the opposite of 7. Like, I think there's some really early foundation stuff that we could do very simply to say, this means the opposite of 7.
When you write a negative sign in front of a number, it means the opposite of 7. Yeah. When we started the episode, one of the things we said is you really want to dive into the meaning of integers. And that's part of it. Yeah, absolutely. Yep. And when you get to a string like this, you're going to have to lean back and kind of review is not the word I want, but you're going to have to acknowledge that kids are going to need a reminder of that, that this is a perfect place to not say, okay, everybody, we've got to get this prerequisite skill down before we can move on. No. That in the midst of it, you could go, wait, as we're looking at this -7, what does that mean? Oh, that's the opposite of 7. Yeah, sure enough. And here's a place to help make that even more generalized, more concrete. Yeah,
Mm-hmm.
for kids. Good. Nice. So if we could if I had just given you a problem like 3 minus 7, you're saying you could have thought about it as 3 plus negative 7. So
Yeah.
what if I gave you a problem like 4 subtract negative 7? And I've written that as 4 subtract, the big subtraction minus sign, and
Yeah.
then parentheses, the opposite of 7, 4 subtract negative 7.
Mm-hmm.
And I'm wondering, this is a subtraction problem as well.
Mm-hmm.
Could we think about subtraction as adding the opposite of the number in this case?
Yeah. So if I'm thinking about it as adding the opposite, then I'm also going to write beside it 4 plus 7,
And why 7?
because the opposite of 7 is 7.
It's hard to say. Yeah. So I've got 2 equations written on my paper right now. 4
Mm-hmm.
subtract negative 7,
Mm-hmm.
and then 4 add the opposite of that negative 7, which is 7. So you're saying 4 subtract negative 7, we could think of as 4 add 7, which is 11.
Mm-hmm.
And that maybe the answer to both of those is 11.
Yeah.
Cool. Could we wonder if we could reason about, we've sort of made this generalization that we can add the opposite, but let's make sure reasoning another way. So I'm looking at that first problem again, 4 subtract negative 7, and I'm going to think about that subtraction symbol now as the distance between the 2 numbers in the problem. What? Why are you laughing?
That's what I actually did the first time.
Oh, that's how you reasoned about it the first time. Okay. Which we would actually expect, because
Yeah.
we're suggesting this comes after that, right?
Yeah.
So can you tell us how you reasoned about 4 subtract negative 7 using distance?
Yeah. You know what I actually did? Is so I drew like a little arrow, but on the like the distance subtraction.
Okay.
Like I thought to myself, I want this to mean distance between 4 and negative 7. So on a number line, I drew 4 and negative 7, and I found the distance between those was 11.
Okay.
And then I knew I had to say, is it positive or negative? So I found the distance, but I need to know, is that a negative 11 or positive 11?
Is the
So
answer to that? Yeah.
So I went back to the problem and I thought to myself, I am subtracting. I started with 4, which is bigger than negative 7.
Okay.
So I'm starting with the bigger number and I'm subtracting something smaller than it. Negative 7 smaller. So then I knew that it was going to be a positive 11.
Just like, because in second grade, if you had a number and you subtracted something smaller than it, you still had money. You were still above sea level. You were still above 0. Nice.
Yep.
So you're saying 4 subtract negative 7 is 11, both ways of reasoning. We just confirmed we can reason through it using distance and removal, or we can use this pattern we've just found where we could add the opposite instead of subtracting. Cool. Let's do that with one last problem. How about negative 6 subtract negative 2? And I'm really curious which way you want to reason first.
Well, so I wrote it down, but then over to the left, I wrote negative 6 plus 2. So adding the opposite of negative 2, which is 2.
Okay.
And then on the right side, I'm drawing negative 2 and negative 6 to find the distance between those.
And would you just mind, since people can't see your drawing, where are negative 2 and negative 6 on the number line?
Yeah. When you just asked me that, I put 0 on there. So I have 0 kind of in the middle. To the left of that 0, I have negative 2.
Okay.
And then further to the left, I put negative 6. And the gap between negative 2 and negative 6 is a gap of 4. But I'm starting this time with a smaller amount. Negative 6 is smaller than negative 2.
So from negative 6, you're removing something larger than negative 6.
So it's going to be negative 4.
It's going to be negative 4. And does that track out what you had said originally is where you had negative 6 plus 2, adding the opposite of negative 2?
Oh, yeah.
And negative 6 plus 2, is that also negative 4?
Yep.
Bam. So we have really nice way of reasoning using distance and removal that we've developed before to substantiate. It looks like when we're subtracting, we can just add the opposite of what we were subtracting. And that seems to play out. Yeah.
Yeah. And neither one of those are, hey, kids, when you see 2 subtraction signs next to each other.
Minus, minus, plus, plus.
Yeah.
Yeah, I mean, you can use that, and I get it, teachers. I really do. In fact, I'm going to go off just a second. We had a teacher in our journey group the other day. It was not about integers. It was about something completely different. Well, in fact, I think it was about scientific notation. Said, I've always in the past done this. It wasn't scientific notation. It was anyway. It doesn't matter.
Times 10.
And they had this mnemonic, and it was like this thing to help kids get answers quickly. And the person in Journey said, I got to tell you, when I just gave kids this rule that they could get answer quickly, they all got answers quickly by the end of the day. When I'm having kids reason and think and understand what's happening, it's not coming as fast. Like, kids aren't all getting the answer at the end of the day. And Kim, I was reminded so strongly, in fact, the middle of the night when I couldn't sleep the other day, what Phil Darrow talks about when he says, yeah, like that's absolutely going to happen because you're building capacity. You're building kids' brains to think in a different way. It's not going to be just a quick and easy answers, but it's also going to stick better.
Mm-hmm.
So will it take longer? Yeah. Will it take more effort? Yeah. Like, there's a reason that we didn't develop operations with integers throughout the history of mankind for a while, right? Like, it took mankind a while to develop these complicated things. It's going to take kids a while to really make sense of it and get it down. It's not going to be as quick, but it will stick so much better. And we'll have kids confident that they can reason through math, that it's not just a bunch of tricks that they're supposed to memorize, not understand, and spit back out and flip a coin about which one to use when. Yeah. That math is actually figure-outable. Bam.
Yeah, absolutely. All right, Pam, we're going to talk about fractions next week.
Hey, I'm so excited. We've been planning to talk about fractions for a hot minute, and we are going to talk about fractions. So y'all, tune in next week. And thank you for tuning in today and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.